Welcome to Study Loop.
So we have a solenoid with 900 turns per meter and a radius of 2.50 centimeters with a current that's increasing at a rate of 60 amps per second. And what we want to calculate is the electric fields at two different radii. So we've got 0.5 centimeters and 1 centimeter. So this problem is a Faraday's law problem. So we can start here with the formula for the electric field in a cylindrically symmetric current distribution. So that's 1 over 2 pi r times the absolute value of the rate of change of the magnetic flux, just like that. So in this case, this r down here is this r up here. So those are the same r's. So all we have to do now is figure out what the actual flux is. So the flux phi b is the area times the magnetic field. The area is pi r squared, right? That's the area of this red circle up here. And the magnetic field is the magnetic field due to a solenoid, which is mu naught times n times I. So mu naught is the classic constant, the permeability of free space. Little n is the number of turns per meters, and I is the current in the coil. So that's the flux. Therefore, the rate of change of the flux. So none of these variables are changing except I. So the rate of change passes through all of these things. And what we're left with is pi r squared mu naught n di dt, or delta I delta t, right? These are the same thing. So now we know all the variables, so we can substitute this back there for the rate change of magnetic flux. So we're going to have E is, so there's going to be some cancellations, right? So there's going to be a cancellation, but let's just write it out. So it's 1 over 2 pi r times pi r squared times mu naught n di dt. And you can see there's some cancellations there. So this pi goes away, this pi goes away, this r goes away. And we're left with a final formula. The electric field is 1/2 times mu naught times r times n times di dt. Now we can substitute our numbers into this formula. So for A, that just means that r is 0.5 centimeters. So the electric field is 1/2 times 4 pi times 10 to the minus 7 newtons per ampere squared times our 0.500 centimeters. Actually, we should be a bit careful and convert that to meters. 0.0500 meters. We have to make sure we're in SI units here. N is the number of turns per meter, so that's just 900 per meter. And di dt was given to us, that's 60 amperes per second. And that is the final answer of 1.7 times 10 to the minus 4 newtons per coulomb. So that's part A. And for part B, so you can, of course, just substitute the numbers back into the same formula, but you can also notice that this formula that we have here is proportional to R. So since this R for B is twice this R, all we really have to do is multiply our answer for A times 2. So we can just multiply that by 2. So you should find that this is about 3.4 times 10 to the minus 4 newtons per coulomb. And that is the full solution to the problem.